Hello guys, welcome to Num Academy. Today we are dealing with the session of trigonometric functions. The trigonometric ratios are the ratios between the two sides of a right angled triangle with respect to an angle, and hence they are real numbers. The angle theta taken into consideration may be acute, obtuse or right angle. Various trigonometric formulas related to the basic trigonometric ratios which must remember include: first one, sin square theta plus cos square theta equals to 1. Second one, sec square theta minus tan square theta equals to 1. Third one, cosec square theta minus cot square theta equals to 1. Moving on to the next point, sin theta into cosec theta equals tan theta into cot theta equals cos theta into sec theta equals to 1. This means cosec theta equals 1 by sin theta, tan theta equals 1 by cot theta, and sec theta equals 1 by cos theta. Fifth point, sin square theta plus cos square theta equals to 1. So, each of them is numerically less than 1. That means modulus of sin theta and modulus of cos theta is less than or equals to 1. Similar to this, the cosec theta lies between minus and 1 and sec theta lies between minus 1 and 1. Eighth one, tan theta and cot theta may take any real values. The trigonometric ratios can be either positive or negative depending on the quadrant in which they lie. In the given figure, quadrant 1, all the functions are positive, means sine, cos, secant, cosecant, tangent and cotangent. All the ratios are positive. In the second quadrant, sine and cosecants are positive. Rest all ratios are negative. In the quadrant 3, tangent and cotangents are positive. Rest all are negative. In quadrant 4, cosine and secants are positive. The range of the function f from x to y is the set of all images of f of x which belongs to the y. That is, range f equals f of x belongs to y where x belongs to x. Domains and range of the trigonometric functions. Guys, in the given below table, you can see the trigonometric functions and their domains and ranges. Sin x having the domain of the real numbers and the range which lies between minus 1 and 1. And cos x having the range domain of r and the range of minus 1 and 1. Similarly, tan x, cosecant x, sec x and cot x are given. Please, students, note down the values. The below table of the basic ratios for some frequently used angles. These formulas must be memorized as are used in almost all the questions. The angle is 0 degree. The sin x will be 0. For 90 degree. In radians, it's pi by 2. The value of sin x is 1. 180 degree, which is pi. In the value of sin x is 0. The angle 270 degree, which is 3 pi by 2. The value of sin x is minus 1. The angle 360 is 2 pi and the value of sin x is 0. The values of various trigonometric ratios vary in different quadrants. The variation is listed below quadrant wise. Sine increases from 0 to 1 in first quadrant. Similarly, in first quadrant, cosine decreases from 1 to 0, tangent increases from 0 to infinity, cotangent decreases from infinity to 0, secant increases from 1 to infinity, cosecant decreases from infinity to 1. In the second quadrant, sine decreases from 1 to 0, cosine decreases from 0 to minus 1, tangent increases from minus infinity to 0, cotangent decreases from 0 to minus infinity, secant increases from minus infinity to minus 1, and cosecant increases from 1 to infinity. In the third quadrant, sine decreases from 0 to minus 1, cosine increases from minus 1 to 0, tangent increases from 0 to infinity, cotangent decreases from infinity to 0, secant decreases from minus 1 to minus infinity, cosecant increases from minus infinity to minus 1. In the fourth quadrant, sine increases from minus 1 to 0, cosine increases from 0 to 1, tangent increases from minus infinity to 0, cotangent decreases from 0 to minus infinity, secant decreases from infinity to 1, cosecant decreases from minus 1 to infinity. And after these four quadrants means after 360 degree, the values repeated again and again similar to these four quadrants. The reciprocals of function have the same period as that of the original function. If period f of x is t, then that of k f of x plus b is t by mod a. Hence, period is affected by coefficient of x only. If f of x has its period t and g of x has its period m, then a f of x plus b into g of x has a period less than LCM of t and m. Moreover, if f of x and g of x are basic trigonometric functions, then period of a into f of x plus b into g of x equals to LCM of t and m, where t and n are the periods of f of x and g of x respectively. If a constant is added, subtracted, multiplied or divided in a periodic function, its period is unaffected. The graph given below are some basic trigonometric function graphs where x-axis indicate the angle and y-axis the values. Here in the first graph, it's a graph of sin x where we can see that the value of sin x increases from 0 to 1 and in the interval 0 to pi by 2 and then decreases from 1 to 0 in the interval of pi by 2 to pi. Similarly, we can see the other graphs also. Here, cos x decreases from 1 to 0 in the interval of 0 to pi and then further decreases from 0 to minus 1 in the interval of pi by 2 to pi. Tan theta or the graph of tan is increases from 0 to infinity in the interval of 0 to pi by 2 and we can also say that the as the tan theta is infinite, so it's not touching the pi by 2 line. Similarly, the sec theta, cosec theta and cot theta graphs also can be seen here. The trigonometric equations and the identities. A function f of x is said to be periodic if there exists some period t which is greater than 0 such that f of x plus t equals to f of x for all x in the domain of f of x. In case the t in the definition of period of f of x is the smallest positive real number, then this t is called period of f of x. Periods of various trigonometric functions are listed below. First one, sin x has a period of 2 pi, cos x has a period of 2 pi. We all know that the sine function increases from 0 to 1 in the interval of 0 to pi by 2, and then decreases from 1 to 0, and then increases decreases in the third quadrant 0 to -1, and then increases from -1 to 0 in the fourth quadrant. So we can say the sin x has a period of 2 pi, and similarly cos x has a period of 2 pi, tan x has a period of pi. Sine of ax plus b, cos of ax plus b, sec of ax plus b, cosec of ax plus b all are the period of 2 pi by a. Tan of ax plus b and cot of ax plus b have a period of pi by a. Modulus of sine of ax plus b, modulus of cos of ax plus b, modulus of sec of ax plus b, modulus of cosec of ax plus b, all are period pi by a. Modulus of tan of x plus b and modulus of cot of x plus b have a period of pi by 2a. Sum and difference formulas of trigonometric ratios. Sine of x a plus b equals sin a into cos b plus cos a into sin b. Sine of a minus b equals sin a into cos b minus cos a into sin b. Cos of ax plus b equals cos a into cos b minus sin a into sin b. Cos of a minus b equals cos a into cos b plus sin a into sin b. Tan of ax plus b equals tan a plus tan b divided by 1 minus tan a into tan b. Tan of a minus b equals tan a minus tan b whole thing divided by 1 plus tan a into tan b. Tan of pi by 4 plus theta equals 1 plus tan theta divided by 1 minus tan theta. Tan of pi by 4 minus theta equals 1 minus tan theta divided by 1 plus tan theta. Cot of a plus b equals cot a into cot b minus 1 divided by cot a plus cot b. Cot of a minus b equals cot a into cot b plus 1 whole thing divided by cot b into cot a. Hope you all know the proofs of this, as it has come already in your first PUC. Moving on to the next thing, double or triple angle identities. Sin 2x equals 2 sin x into cos x. Cos 2x equals cos square x minus sin square x equals 1 minus 2 sin square x, which is equals 2 cos square x minus 1. These are all forms can be obtained by substituting cos square x equals 1 minus sin square x or sin square x equals 1 minus cos square x. Tan 2x equals 2 tan x divided by 1 minus tan square x. Sin 3x equals 3 sin x minus 4 sin cube x. cos 3x equals 4 cos cube x minus 3 cos x. Tan 3x equals 3 tan x minus tan cube x, whole thing divided by 1 minus 3 tan square x. For angles A, B and C, we have sine of A plus B plus C equals sine A into cos B into cos C plus cos A into sine B into cos C plus cos A into cos B into sine C minus sine A into sine B into sine C. Similarly, for cos of A plus B plus C equals cos A into cos B into cos C minus cos A into sin B into sin C minus sin A into cos B into sin C minus sin A into sin B into cos C. And tan of A plus B plus C equals tan A plus tan B plus tan C minus tan A into tan B into tan C, whole thing divided by 1 minus tan A into tan B minus tan B into tan C minus tan A into tan C. Cot of A plus B plus C equals cot A into cot B into cot C minus cot A minus cot B minus cot C, whole thing divided by cot A into cot B plus cot B into cot C plus cot C into cot A minus 1. Thus some other trigonometric formulas such as transformation formulas. 2 sin A into cos B equals sine of A plus B plus sine of A minus B. 2 cos A into sin B equals sine of A plus B minus sine of A minus B. 2 cos A into cos B equals cos of A plus B plus cos of A minus B. 2 sin A into sin B equals cos of A plus B minus cos of A plus B. Sin A plus sin B equals 2 into sin of A plus B by 2 into cos of A minus B by 2. Sin A minus sin B equals 2 into sin of A minus B by 2 into cos of A plus B by 2. Cos A plus cos B equals 2 into cos of A plus B by 2 into cos of A minus B by 2. Next one, cos A minus cos B equals 2 into sin of A plus B by 2 into sin of B minus A by 2. Ninth one, tan A plus or minus tan B equals sin of A plus B or A minus B divided by cos A into cos B. Cot A plus or minus cot B equals sin of B plus or minus A divided by sin A into sin B. Method of solving trigonometric functions or equations. The first step is, if possible, reduce the equation in terms of any one variable, preferably x. Then solve the equation as you used in the case of single variable. Step 2. Try to derive the linear or algebraic simultaneous equations from the given trigonometric equations and solve them as algebraic simultaneous equation. Step 3. At times, you might be required to make certain substitution. It would be beneficial when the system has only two trigonometric functions. Some results which are useful for the solving trigonometric equations. First one, sin theta equals sin A and cos theta equals cos A, which implies theta equals 2n pi plus A. This is the general solution of the angle theta. Second one, sin theta equals 0. That implies theta equals n pi. Cos theta equals to 0, which implies theta equals 2n plus 1 into pi by 2. Tan theta equals 0. That implies theta can take the values of n pi. Sin theta equals sin a. That means theta equals n pi plus minus 1 whole to the power n into a, where a belongs to the range of minus pi by 2 to pi by 2. Cos theta equals cos a, which implies theta equals 2n pi plus or minus a, where a belongs to the interval 0 to pi. Tan theta equals tan a, which implies theta equals n pi plus a, where a belongs to the closed interval minus pi by 2 to pi by 2. Sin theta equals to 1, that implies theta equals 4n plus 1 into pi whole thing divided by 2. Sin theta equals minus 1, that implies theta equals 4n minus 1 into pi whole thing divided by 2. Sin theta equals minus 1, that implies 2n plus 1 whole thing into pi divided by 2. Modulus of sin theta equals to 1, that means theta can take the values 2 and pi. Cos theta equals to 1, that implies theta can take the values 2n plus 1 into pi. Modulus of cos theta equals to 1, that means theta equals to n pi. Guys, let's move to the problems. Problem number 1. If 2 sin theta minus cos theta divided by cos theta plus sin theta equals to 1, then the value of cot theta is option A 1 by 2, option B 1 by 3, option 3 1 by, option C 3, option D 2. The correct option is A. Let's see the solution of this problem. Divide the numerator and denominator by sin theta, which gives 2 minus cos theta by sin theta, that is nothing but cot theta, divided by cos theta by sin theta plus 1. So, we left with the equation 2 minus cot theta divided by 1 plus cot theta equals to 1. So, 2 minus cot theta equals to 1 plus cot theta. Hence, cot theta equals 1 by 2. So, the correct option is A. Let's move on to the second problem. If cot of pi by 2 minus theta equals to root 3, then the value of cos theta is option A 0, option B 1 by root 2, option C 1 by 2, option D 1. The correct option is C, because cot of pi by 2 minus theta equals to root 3 is the given equation. That means tan theta equals to 3. Because cot of pi by 2 minus theta is nothing but tan theta. Therefore, the angle theta equals to 60 degree. This is the standard angle. Hope you all know the standard angles as 0 degree, 90 degree, 30 degree, 60 degree and 45 degree. So, the cos theta value will be 1 by 2. Therefore, the right option is C. If tan to the power 4 theta plus tan square theta equals to 1, then the value of cos to the power 4 theta plus cos square theta is option A 8, option B 10, option C 1, option D 2. The correct option is C. We have the given equation tan to the power 4 theta plus tan square theta equals to 1. Take out tan square theta common. Then we'll left with tan square theta plus 1. We know the basic common identity, that is tan square theta minus sec square theta equals to sec square theta minus tan square theta equals to 1. That means tan square theta plus 1 equals to sec square theta. So tan square theta into sec square theta equals to 1. Then convert tan square and sec square in terms of sine square and cos square. Then we left with sine square theta divided by cos to the power 4 theta equals to 1, which implies sine square theta equals cos to the power 4 theta. Convert sine square theta into 1 minus cos square theta. Then we have cos to the power 4 theta plus cos square theta equals to 1. So the correct option will be 3. The next question is the value of sine 45 degree plus theta minus cos 45 degree minus theta is option A 1, option B 0, option C 2 cos theta, option D 2 sin theta. The correct option is B. Sine 45 degree plus theta minus cos 45 degree minus, here make the conversion that sine of 90 minus theta equals to cos theta. So we can apply that here. Sine of 45 degree plus theta minus cos of 45 degree minus theta equals sine of 90 minus 45 degree minus theta minus cos of 45 degree minus theta. Then the conversion will be cos of 45 degree minus theta minus cos of 45 degree minus theta. So both the term will cancel. So we left with the 0. Hence the correct option is B, 0. Next question is if cot A plus cosec A equals A and A is an acute angle, then the value of cos A is option A 4 by 5, option B 1, option C 1 by 2, option D 1 by root 3. The correct option is A. Here cot A plus cosec A equals to 3. Convert cot in terms of cos A by sin A and cosec in terms of 1 by sin A, which is equals to 3. Cos A plus 1 equals to 3 sin A. Squaring on both sides, cos square A plus 1 plus 2 cos A equals 9 sin square A. Convert sin square A into 1 minus cos square A. Then we have an equation called 10 cos square A plus 2 cos A minus 8 equals to 0. That implies divide the whole equation by 2. Then we have 5 cos square A plus cos A minus 4 equals to 0. It's in the form of a quadratic equation. Solve the quadratic equation and you can have the values for cos A. So as A is the acute angle, we have left with cos A equals to 4 by 5. Hence the option is A, correct answer. Find the value of sin square 10 plus sin square 20 plus sin square 30 plus and so on up to sin square 80. The option A is 2, option B is 3, option C is 1, option D is 4. The correct answer is D, because we can rewrite the above equation sin square 10 plus sin square 20 plus sin square 30 plus and so on up to sine square 80 as sine square 10 plus sine square 80 plus sine square 20 plus sine square 70 plus sine square 30 plus sine square 60 plus sine square 40 plus sine square 50. Here we just rearrange the terms. We know that sine square x plus sine square 90 minus x equals to 1 because sine square 90 minus x is cos square x. Hence, here sine square 10 plus sine square of 90 minus 80, which is nothing but cos square 10, it gives the answer 1. So, 1 plus 1 plus 1 plus 1, which is nothing but 4. Hence, the correct option is D. Move on to the next question. Find the value of 16 divided by root 3 into cos 50 into cos 10 into cos 110 into cos 60. Option A 1, option B 2, option C minus 1, option D minus 2. Here the correct option is C because we know that cos x into cos of 60 minus x into cos of 60 plus x equals cos x into cos x into cos 60 plus sin x into sin 60 into cos x into cos 60 minus sin x into sin 60, which is equals cos x into cos square x into cos square 60 minus sin square x into sin square 60, which is equals cos x into 1 by 4 cos square x minus 3 by 4 sin square x, because value of cos 60 is 1 by 2, hence the square is 1 by 4. Similarly, the value of sin square 60 degree will be 3 by 4 because sin 60 is root 3 by 2, which is equals 1 by 4 into cos cube x minus 3 cos x whole thing into 1 minus cos square x, which is equals 1 by 4 into 4 cos cube x minus 3 cos x equals to 1 by 4 into cos 3x. 4 cos cube x minus 3 cos x is the formula of cos 3x. Hence, cos x degree into cos of 60 minus x degree into cos of 60 plus x degree equals 1 by 4 into cos of 3x. Hence, cos 50 into cos 10 into cos 110 will become 1 by 4 times the cos 150 degree, which is equals 1 by 4 into minus root 3 by 2 equals minus root 3 by 8. So, cos 6 degree equals 1 by 2. Put the values in equations A and B. Then we have 16 by root 3 into cos 50 into cos 10 into cos 110 into cos 60. We will get 16 by root 3 into minus root 3 by 8 whole thing into 1 by 2, which is equals minus 1, as the correct option is 3. Find the value of cos square theta into root of 1 plus sin theta divided by 1 minus sin theta plus root of 1 minus sin theta divided by 1 plus sin theta. Option A cos theta, option B cos theta by 2, option C 2 cos theta, option D root 2 cos theta. The correct option is 3 because cos square into root of 1 plus sin theta divided by 1 minus sin theta plus root of 1 minus sin theta divided by 1 plus sin theta can also be written as cos square theta into multiplying by the conjugate of 1 plus sin theta and 1 minus sin theta, that is root of 1 plus sin theta into 1 plus sin theta divided by 1 minus sin theta into 1 plus sin theta plus root of 1 minus sine theta into 1 minus sine theta divided by 1 plus sine theta into 1 minus sine theta. That gives cos square theta into root of 1 plus sine theta the whole square divided by 1 minus sine square theta, which is nothing but cos square theta, plus root of 1 minus sine theta the whole square divided by 1 minus sine square theta, which is nothing but cos theta. Hence, we left with cos square theta into root of 1 plus sine theta the whole square divided by cos square theta plus root of 1 minus sine theta the whole square divided by cos square theta. Removing the roots gives cos square theta into 1 plus sine theta divided by cos theta plus 1 minus sine theta divided by cos theta. That is equals cos square theta into 1 plus sine theta plus 1 minus sine theta divided by cos theta. Sine theta will get cancelled. 1 plus 1 is 2. 2 divided by cos theta into cos square theta. Cos theta and cos square theta, 1 cos theta will get cancelled. Hence, we left with 2 cos theta. Hence, the correct option is C. If sine 21 degree equals to x by y, then secant 21 degree minus sine 69 degree is equals to option A, x square divided by y root of y square minus x square. Option B, y square divided by y root of y square minus x square. Option C, x square divided by y into root of x square minus y square. Option D, y divided by x into root of x square minus y square. The correct option is A. The given equation is sine of 21 degree equals to x by y. Then cos of 21 degree will be root of 1 minus sine 21 degree the whole square. That is equals root of 1 minus x by y the whole square. Hence, the cos 21 degree will become root of y square minus x square divided by y. Hence, sec 21 degree is the reciprocal of cos 21 degree, which becomes y divided by root of y square minus x square. According to the question, sec 21 degree minus sine 69 degree. Then sine 69 degree can be converted as sine of 90 minus 21, which is nothing but 69. Hence, sine is converted into cos. That implies sec 21 degree minus cos 21 degree equals y divided by root of y square minus x square minus root of y square minus x square divided by y. Simplifying this, we get x square divided by y into root of y square minus x square. Hence, the correct option is A. Next question. Find the value of sine 35 divided by cos 55 degree the whole square plus cos 55 degree divided by sine 35 degree the whole square minus 2 cos 30 degree. Option A 0, option B 1 minus root 3, option C 2 minus root 3, option D 3. The correct option is C. The sine 35 can be converted into sine of 90 minus 35 degree and cos 55 can be converted into cos of 90 minus 55, that is sine 35 degree. Hence, sine 35 degree divided by cos 55 degree can written as cos 55 degree divided by cos 55 degree, which is nothing but 1. Similarly, cos 55 degree divided by sine 35 degree can be written as Sine 35 degree divided by sine 35 degree, nothing but 1. So 1 square plus 1 square minus 2 cos 30 degree. Cos 30 degree is root 3 by 2. 2 will get cancelled, hence 1 plus 1 minus root 3, which is equals 2 minus root 3. Hence the correct option is C. Thank you for watching. Please like and share and subscribe our YouTube channel.